Very good afternoon to all of you. Can you hear me? Please tell me. Am I audible to all of you? Please tell me. कौन है वहाँ पे? कौन कौन आया आज के लेक्चर को? Please tell me. Am I audible? Yes or no? Sonal is saying yes, sir. Okay. Very good afternoon to all of you. Welcome back to the chemistry lecture. बहुत दिनों के बाद मिल रहे हम लोग, नहीं? Yes or no? So, how was your exam? Tell me about your exam. Was it difficult or was it easy? कैसी थी आप लोगों की एग्जाम? इंटरनल एग्जाम आई एम टॉकिंग अबाउट. प्लीज रिमेंबर दिस. इंटरनल एग्जामिनेशन ऑफ TY BSc. How was that exam? It was easy or it was difficult? बोलो जल्दी से, कौन कौन है आज लेक्चर को? No one is there. अरे, how was your exam? जल्दी से बोलो भाई, कहाँ पे हो आप लोग? No, nor easy, nor difficult. Medium. Ankush is saying it was medium. Okay, and what about others? What about others? What about others? Moderate. पूजाला moderate गेली. So what we were talking about? Chalo, we will start the lectures. What we were talking? We were talking about MOT, that is molecular orbital theory. In the last lecture हम लोगों ने I think almost 1 month before हम लोगों का last lecture हुआ था, ठीक है? So in that lecture what we have seen? We have seen the introduction of molecular orbital theory. Then what is the need of molecular orbital theory, or how this molecular orbital theory is superior than valence bond theory, molecular orbital theory and Werner's coordination theory, that we have seen. Yes or no? In the last lecture. Then also we have seen the assumptions of molecular orbital theory, key points of molecular orbital theory, that also we have seen in the last lecture. So what we will do today, we will go to the next point. In today's lecture we will see the application of MOT. What we will see, we will apply this molecular orbital theory to the octahedral complexes. Those octahedral complexes which are having or which does not has a pi bond, so we will apply molecular orbital theory to the coordination complex without pi bond, to the coordination complex without pi bond, that we will see. Then before that we will see some symmetry symbols. There are some symmetry symbols for metal orbitals and ligand orbitals. So in these molecular orbital theory, we will not use 4s orbital, 3p orbital and 4d orbital. Instead of, we will use their symmetry symbol. Please remember this. Whatever the symmetry symbols are there, we will see the symmetry symbol first, and then that symmetry symbol we will use. in molecular orbital theory. In molecular orbital theory, 4s, 3s, 4d, 5d, these orbitals are not used. Or we cannot see. Supreet is saying good. Okay, Supreetला चांगली गेली exam म्हणजे. So please remember, in molecular orbital theory, we will not use the 4s, 3d, 4p orbitals. Instead of these orbitals, we will use their symmetry symbols. For example, we have seen 5d orbitals. There are two symmetry symbols for 5d orbitals. Can anybody tell me the can anybody tell me the symmetry symbols for 5d orbitals? Two symmetry symbols are there for 5d orbitals. So anybody knows that symmetry symbol? Hmm? You know that. I know. You know that symmetry symbols. Which symmetry symbols are there for 5d orbitals? And you know that two symmetry symbols are there. We have seen that symmetry symbol in CFT also, and in MOT also we will see. Okay, so tell me which symmetry symbols are there. Don't worry, I will teach you how to give symmetry symbol and that. Okay, nobody knows the symmetry symbol for 5d orbital. Hmm? Okay, no problem. So first we will see the symmetry symbol, and then we will apply this molecular orbital theory to the coordination complexes. Okay, yes or no? Now shall I start the lecture? Shall I start the lecture? Yes or no? Is everybody ready? जल्दी से बोलो मुझे चैट सेक्शन में. Is everybody ready? Vikram is saying yes sir. Jay is also saying yes sir. Then Mansi, Amit, Snehal. What about others? Krishna Priya is also saying yes sir. Okay. So we'll start. Okay, so this is your lecture number 2, molecular orbital theory lecture number 2. Okay, so I think we will finish this chapter within today we will not finish. Next lecture we will finish this chapter. Okay, so your syllabus is over for first term. Your first term is over of your last year. Okay, chalo, so we will start the lecture. क्या है? ओके, assumptions of molecular orbital theory. ठीक है, so we'll have a very quick look over the assumptions of molecular orbital theory. जल्दी से हम लोग assumptions of molecular orbital theory देख लेते हैं. ठीक है, तो so that you will get in touch to the MOT. ठीक है, so first assumption of molecular orbital theory. क्या है first assumptions? आपके स्क्रीन पे the central metal atom contributes 9 atomic orbital for the bonding. This is the first assumptions. Central metal orbital contributes 9 atomic orbitals for the bondings. Out of that 9, 5 orbitals are d orbitals, 3 orbitals are p orbital, and 1 orbital is s orbital. Please remember this. Okay. See, these 9 atomic orbitals are used for the molecular orbital theory. S orbital px, py, pz, dx square minus y square, dz square, dxy, dxz, and dyz. So these 9 atomic orbitals are used for molecular orbital theory. Then next assumptions, out of these 9 atomic orbital, only 6 orbital are used for the sigma bond formations. Out of these uh, 9 atomic orbital, only 6 orbitals are used for a sigma bond formation. Which 6 orbitals are used? Yes, px, py, pz, dx square minus y square and dz square orbital. Why only these six orbitals are used? Because of their lobes are sorry, their lobes are directed along the axis. Simple reasoning. Then assumption number 3. Ligand contributes s orbital and or some combination of s and p orbital to form a sigma bonds. So ligand gives s orbital or it will give the combination of s and p orbital to form a sigma bond. So these s and combination of s and p orbital, they get interact with the metal orbital and forms a sigma bond. Then next, assumption number 4. The six ligand orbitals combines and forms a new set of orbital called as a ligand group orbital. In short, it is also called as a LGOs. So these six ligand, they get combines and forms a new set of orbital, and that new set of orbital is called as a ligand group orbital, or it is also called as a LGOs. Then fifth assumption, metal orbital combines with ligand group orbitals. Metal orbital combines with LGOs with matching symmetry. This word is very very important, matching symmetry, and forms a sigma bonding and sigma anti-bonding. So due to the combination of ligand group orbitals with the metal orbital, there are formation of sigma bonding and sigma anti-bonding orbitals, and these sigma anti-bonding orbitals, they are generally indicated by star. Anti-bonding orbital, they are indicated by star, and these anti-bonding orbital, they has their energy is more as compared to the sigma bonding orbital. Sigma bonding orbital has energy less as compared to anti-bonding orbital. Then the assumption number 6, if ligand contains pi orbitals, they are also made to combine among themselves to form a new set of symmetry orbitals, and these ligand orbital will then combine with the metal orbital with matching symmetry and to form a pi bonding and pi anti-bonding. Like as I have said you that in case of sigma bonding, there is also formation of pi bond takes place, and same as like sigma bonding, pi bonding and pi anti-bonding orbital will get formed. Then next, seventh assumption or last assumption, the total number of electrons of metal. क्या करना है आप लोगों को? You have to count the electrons from metal as well as electrons from ligands are then filled in MOs, that is molecular orbital, according to the above principle, Hund's rule and Pauli's exclusion principle. So you have to follow these three rules while filling the electrons in molecular orbitals. Okay, so these are the assumptions of molecular orbital theory. Okay, have you understood these assumptions of molecular orbital theory? Then we will go to the molecular orbital treatment to the octahedral complex without pi bonding. There are two cases. There are two cases. Molecular orbital treatment to the octahedral complex with pi bonding is there, and this is without pi bonding. So we will see first the octahedral complexes without pi bonding, and in the next lecture we will see the octahedral complexes with pi bonding. Generally without pi bonding is very very important, or generally question are based on this topic only, that is without pi bonding. Okay, so we will study deeply without pi bonding only. Okay, with pi bonding is also there, but that is some critically diagram is there, different diagram is there. Okay, so have you understood first the assumptions? In the last lecture also we have discussed the assumptions of molecular orbital theory. Okay, okay, then we will go to the next point, that is molecular orbital treatment to the octahedral complex without pi bonding. And the first point in this is the octahedral complex. In octahedral complex, orbitals which are involved in sigma bonding is 4s, 4p x, 4py, 4pz, 3dz square and 3dx square minus y square. So these uh, orbitals, they are used in octahedral complexes, that is for 4s orbital, 4p orbital and 3d orbitals. Then this T2G set, that is 3dxy, 3dxz, 3dyz, they does not participate in sigma bonding, but they can participate in pi bonding. So this T2G orbital, whatever the T2G set is there, dxy, dxz and dyz, this T2G set is does not participate in sigma bonding, but it can participate in pi bonding. Okay, then we will see the symmetry symbol of metal and ligand orbital. I have told you we will not use 4s and 3d and 4p orbitals here. We will use, instead of these, we will use symmetric symbols while discussing the molecular orbital theories. Okay, so let us learn the symmetric symbol of metal and ligand. First symmetry symbol of s orbital. So instead of s orbital you have to use a1g. For example, this is of metal. ये आप लोगों को एग्जाम्पल में तौर के एग्जाम्पल के तौर के यहाँ पे दिस इज द सिमेट्री सिंबल फॉर मेटल ऑर्बिटल एंड दिस इज सिमेट्री सिंबल फॉर लिगेंड ऑर्बिटल. ठीक है, सो इंस्टेड ऑफ एस ऑर्बिटल यू हैव टू यूज A1G orbital. Why A1G? Because A is a singly degenerate. A indicates singly degenerate. G indicates it is a G-red orbital. D indicates it is G-red orbital. So symmetry symbol for S orbital is A1G. Please remember this. Or if you have pen and notebook, you can write down this symmetry symbol, which is very important. Okay. So symmetry symbol for S orbital is A1G. Then the next symmetry symbol. The symmetry symbol for 3p orbital, that is px, py and pz orbital. For metal it is T1u and for ligand also it is T1u. Why T? Why T is here? Because they are triply degenerate. 3d orbital, 3p orbitals are there. Na? That's why T is there. That means triply degenerate. And U means what? U means what? It is ungeared. U means what? It is ungeared. And in case of ligand also T1u you have to use. So symmetry symbol for 3p orbital is T1u. Then the next symmetry symbol for d orbital, that is dz square and dx square minus y square. ये मैंने आप लोगों को पूछा था. Symmetry symbol for d orbital. So first symmetry symbol for d orbital, these two d orbital is Eg. And why Eg? That you know very well. E means it is a doubly degenerate, 2d orbitals which are having same energy level. So it is a E, that is doubly degenerate, and G means it is a G-red orbital. In case of ligand also it is a Eg. Then dxz, dyz, dxy orbital, and the symmetry symbol is T2g. Symmetry symbol is T2g. Why T again here? Because of triply degenerate. 3d orbitals are there, and these 3d orbital they has their similar energy level. And G means it is a G-red. G means it is a G-red. And in case of ligand also T2g symbol is there. So instead of this s orbital, p orbital, dz square, dx square minus y square and dxyz, you have to use their symmetry symbols. These symmetry symbols you have to use. This symmetry symbol you have to use. Now tell me, have you understood this symmetry symbol or not? Or if you have any problem, then also you can ask me. Uh, if no problem, we will go to the molecular orbital treatment directly. We will go to the molecular orbital treatment directly. Any problem? बोलो, है क्या किसी को प्रॉब्लम सिमेट्री सिंबल में? Where are you guys? Are you there in the lecture or you left? Sonal, only Sonal is attending my lecture. No, nobody is attending my lecture. Only Sonal is seriously attending my lecture. Sonal is saying no problem. What about others? That means they have some problems. If you have problem, then ask me. Vikram is also there. Vikram is saying no, sir. Okay, chalo. So shall I start the molecular orbital treatment? Are you ready for molecular orbital treatment? Komal is also there. Komal is saying no, sir. Okay, good. So shall I start the MO treatment now, which is the heart of molecular orbital theory. MO treatment is heart of molecular orbital theory. Now I will request you to take pen and notebook. If you don't have pen and notebook, go take pen and notebook. Then only you will understand the molecular orbital theory. Otherwise you will not understand what is molecular orbital theory, how to construct molecular orbital diagram. Okay, so my request to all of you, take a pen and notebook and draw the molecular orbital diagram. जो कुछ भी मैं एक्सप्लेन करूंगा वो आप लोगों को ड्रॉ करना है. Then and then only, because there will be question for 5 marks based on this molecular orbital theory. If you see the previous year question paper, there is a question based on this topic, molecular orbital theory. Compulsory question रहता है इसके ऊपर for 5 marks. ठीक है. चैतन is saying yes sir. चैतन घेऊन बसलाय म्हणजे चलो. Okay, so we'll see the molecular orbital theory. Now this is the molecular orbital diagram. आपके स्क्रीन पे जो दिख रहा है ना, that is called as a molecular orbital diagram. Whatever you can see on your screen, that is called as molecular orbital diagram. Now what is this molecular diagram? क्या होता है? This molecular diagram consists of three things. क्या है? Molecular orbital diagram consists of three things. First thing it has a metal orbitals, because अगर metal orbital नहीं है तो combination कहाँ से होगा? So first part of MO diagram is you should have metal orbital on the left to my left hand side as far as my position is concerned. So आपके स्क्रीन पे जो दिख रहा है उसके राइट पे मेटल ऑर्बिटल्स आप लोगों को ड्रॉ करना है, और यू कैन से इट इज लेफ्ट. ठीक है. सो ऑन द लेफ्ट side you have to draw the metal orbitals. Which metal orbital you have to draw? Those are involving, or those are participating in MOT. So which orbitals are involved or participating? 3D orbitals are participating, 4s orbital is participating, and 4p orbital is participating. ठीक है. Now 3D orbitals means there are 5 orbitals. और कौन से 5 orbitals होते हैं? You know that very well, that is T2g and EG. These 5D orbitals are there. Then 1s orbitals, 1s orbital is involved. 1s orbital कौन सा होता है? What is the symmetry symbol for 1s orbital? What is the symmetry symbol for 1s orbital? That is A1g. So draw the one box and 4s orbital and 1g. Here if you see here, 4s orbital is involved, and the symmetry symbol for this 4s orbital is A1g, and you have to draw that orbital. You have to draw the box diagram. Then 4p orbitals are there, and its symmetry symbol is T1u. 4p orbital is there and its symmetry symbol is T1u. So what you have to do, you have to arrange, or you have to order these 3D, 4s and 4p orbital according to their energy. So for 3D orbital is lower in energy, then 4s orbital, and then 4p orbital. You know that energy very well now. And then the symmetry symbol for 3D orbitals are T2g and EG, that you know. Symmetry symbol is for s orbital is A1g, and symmetry symbol for 4p orbital is T1u. ठीक है. So based on this orbital number you have to draw the box. Here 3D orbitals are there. D orbitals, they have 5 subcells, so you have to draw the 5 box. S orbital is only 1 and p orbital is 3, so you have to draw the 3 box. So this is the first part, your molecular orbital diagram. This is the first part, that is metal orbital, which is on your right. ठीक है. Okay, then left, sorry, on the right hand side what you have to draw? Ligand orbitals you have to draw. On the right hand side you have to draw the ligand orbitals. And how many ligand orbitals are involved? See here, coordination number of octahedral geometry. Coordination number in case of octahedral geometry is 6. Coordination number for octahedral geometry is 6. So 6 ligand orbitals are involved in the combination. 6 ligand orbitals are involved in the combination, and you have to draw the 6 boxes. And which 6 ligand orbitals are involved? कौन से 6 ligand orbitals are involved? That is A1g, that is A1G, T1U and each. This A1G means yes orbital. This A1G means it is yes orbital. This T1U means it is p orbitals, and Eg means it is d orbitals. Okay, so these 6 orbitals they are involved in combination. So you have to draw these 6 orbital, and at the middle, यहाँ पे आप लोगों को दिख रहा है ना, this is the middle part of your MO diagram. At the middle you have to draw the MOs. At the middle, what you have to draw? You have to draw the MOs, that is molecular orbitals. At the middle you have to draw the MOs. So how will you draw? Again you have to follow the energy sequence. Again you have to follow the sequence. So according to the quantum mechanics, A1G orbital has lower energy. According to the quantum mechanics, A1G orbital is lower in energy than T1U, then Eg, and then T2G. T2G orbital remains non-bonding. T2G orbital remains non-bonding, and these orbitals which are shown by black color, they are called as a bonding orbital. They are called as a bonding orbital because their energy is less as compared to this uh, metal orbital and ligand orbital. And these orbital, that is Eg star, A1G star, T1U star, this star indicates what? Star indicates what? Tell me. Star indicates what? They are anti-bonding orbital, and anti-bonding orbital has higher energy level than metal orbital and ligand orbital. So first what you have to do, you have to draw the lowest energy orbital, that is A1G. You have to draw lowest energy orbital, that is A1G. So now where A1G? Here, yes orbital. So you have to draw the dotted line from yes orbital A1G, and here you have to draw the one box and give the name to the box is A1G. And here also same A1G orbital will take part, it will get combined here. So A1G orbital from metal and A1G orbital from ligand, they will get combined and forms a metal bonding orbital or sigma bonding orbital, that is A1G. That is A1G. Okay. Then next is T1U. So T1U orbital from metal, that is p orbitals. Here T1U is there. So T1U orbital from metal and T1U orbital from ligand, they will combine and they will get form a sigma bonding orbital, that is T1U. This is a sigma bonding orbital. Next is Eg orbital. Eg orbital from these Eg orbital from metal and this Eg orbital from ligand, they will get combined and forms a sigma bonding orbital, that is Eg. Now here T1U, T means triply degenerate, E means doubly degenerate, you have to draw the two boxes, and A means singly degenerate, you have to draw only one box. You have to draw only one box. Then this T2G orbital, I have told you this T2G orbital, they will not take part in the bonding. They will remain as the anti-bonding. They will remain as a non-bonding. Sorry, they will remain as a non-bonding. Now you people tell me why this T2G orbital they will not take part in bonding. ठीक है, आप लोगों को मुझे बोलना है. Then next is Eg star orbital. So I have told you the sigma bonding. Similarly, Eg orbital they will form a sigma anti-bonding orbital. So here Eg orbital I have drawn, and this is indicated by a star. That means it is an anti-bonding orbital which has higher energy than this sigma bonding orbital. Which has higher energy than this sigma bonding orbital. Similarly, you have to draw for A1G. Here A1G is there. Here A1G is there. So here A1G star. That means it is anti-bonding. And last T1U. Here is T1U. This is bonding, and this is red color. I have shown in red color, it is anti-bonding orbital. So in this way you have to construct the molecular orbital diagram. In this way you have to construct the molecular orbital diagram. Have you understood this, or you have any problem? Tell me. If you have any problem, you can ask me. Have you understood this construction of molecular orbital? आप लोगों को समझ में आया है क्या? Construction of molecular orbital for coordination compound or for coordination complexes. It has three parts: metal orbitals at the left, at the right ligand orbitals are there, and in the middle molecular orbitals are there. These metal orbital and ligand orbital, they are atomic orbital. Please remember, these metal orbital and ligand orbital, they are atomic orbital. They will get combined and forms a molecular orbital. If two molecular orbital combines, then what happens? Two molecular orbitals will get formed. Out of that, one is bonding and another one is anti-bonding orbital. Bonding orbital has lower energy and anti-bonding orbital has higher energy. Now have you understood this? Yes or no? बोलो मुझे जल्दी से. अगर आप लोगों को समझ में आया है, then we will go to the next point, that is the filling of electrons in the molecular orbital. Next point is you have to fill the electrons in molecular orbital. Have you understood this or not? Please tell me. If you have any problem, any doubt, you can ask me. Anisha is saying understood, sir. Understood, sir. Okay, what about others? और किसको किसको समझ में आया? कंस्ट्रक्शन ऑफ मॉलिक्यूलर ऑर्बिटल्स और कंस्ट्रक्शन ऑफ मॉलिक्यूलर ऑर्बिटल डायग्राम, which is very important point. It is called as the heart of MOT. This construction of MOs is called as heart of MOT. Please remember this. So this construction of molecular orbital or molecular orbital diagram is very important. Then next part is only to fill the electrons from ligand and electrons from metal. We have to add them and we have to fill according to the energy level, according to the above principle. Okay, have you understood this? Okay, chalo. Then we will see the filling of electrons in MOs. What we will see? Filling of electrons in MOs, and for that we will take one example. This example we will take complex of titanium, aqua complex of titanium. Here aqua complex of titanium, here CMA is titanium, central metal atom is titanium, water is called as the ligand, this 6 is coordination number, and this is a charge on the complex. Now what you have to do? First you have to calculate oxidation state. What you have to do? First you have to calculate oxidation state. Oxidation state of titanium. कितना है oxidation state of titanium? Water is a neutral ligand. You know that now very well. Water is neutral ligand. So charge on the complex is the oxidation state. So charge on the complex is +3. So oxidation state of titanium is also +3. Okay. So what is your next job? Titanium 3+. Write down the valence shell electronic configuration titanium का. क्या है वैलेंस शेल इलेक्ट्रॉनिक कॉन्फ़िगरेशन टिटेनियम इन जीरो ऑक्सीडेशन स्टेट? 4s2 3d2. This is the valence shell electronic configuration of titanium in zero oxidation state. Then in titanium 3+, what will happen? 3 electrons will get removed. So 2 electrons will get removed from 4s orbital and 1 electron will get removed from 3d orbital. So its electronic configuration will become 4s0 3d1. So this is the valence shell electronic configuration of titanium in 3+ oxidation state. This is valence shell electronic configuration of titanium in 3+ oxidation state. Now you understood or you know the D system. So D system is 3d1, which is very important. This you will require. So D system is 3d1. So that means electrons contributed from metal. Electrons contributed from metal is 1. because d system is 1. D orbital contains only one electrons. So electrons contributed from metal is 1, and electrons contributed from ligands are, how many ligands are there? 6 ligands are there. I will write here 6 ligands are there, and each ligand gives 2 electrons for coordinate bond formation. So 6 into 2, total 12 electrons. So electrons contributed from ligands are 12. Electrons contributed from ligands are 12. So total electrons are 13. So total electrons are 13. So 13 electrons are available with you, and these 13 electrons you have to fill in molecular orbitals according to the rules. Okay. So see here, it is a D1 system. I have told you this is D1 electronic system. So 1 electron from metal and 12 electrons from water, that is a ligand. So total 13 electrons you have to fill. So how will you fill these 13 electrons? ठीक है, how will you fill these 13 electrons? So first 2 electrons will go into the lower energy orbital, and A1G is lower energy orbital. So 2 electrons will go into lower energy orbital. 2 electrons will go into the lower energy orbital. Then next lower energy orbital is T1U. So 3 electrons will fill here. Then again 3 electrons will fill. So total 6 plus 2, total 8 electrons we have filled. Total 8 electrons we have filled. Then next lowest energy orbital is EG. Next lowest energy orbital is EG. So here we will fill 2 electrons, and again 2 electrons we will fill. So how many electrons we have filled? 4 plus 6, 10 plus 2, 12. So 1 electrons we will fill in T2G orbital. So what is the electronic configuration? I will write here electronic configuration A1G2, then T1U6, then EG4, and T2G1. This is the electronic configuration. This is the electronic configuration according to the MOT. This is the electronic configuration. क्या है हम लोग देखते हैं एक बार. ठीक है, correct. A1G2, T1U6, EG4, and T2G1. So this is the electronic configuration. Have you understood the molecular orbital diagram? आप लोगों को समझ में आया कि molecular orbital diagram? Have you understood this or not? Very simple, कुछ भी नहीं है इसमें. So here, sorry, I forget to draw the electrons here. So here metal orbitals are there, D system, D1 system. So only 1 electrons will be here, and here 12 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this way you have to fill, because these are electrons from ligands, and these are electrons from metal. Okay. So in this way you have to construct a molecular orbital diagram. Have you understood this or not? Tell me. ये आप लोगों को समझ में आई है क्या molecular orbital diagram? Have you understood this? Yes or no? Where are you guys? Chetan, Krishna Priya, Sonal. Okay, Sonal and Mansi Singh understood. Okay, chalo. Only 2 people, only 2 girls have understood molecular orbital treatment. What about others? Krishna Priya कहाँ पे है? चेतन कहाँ पे है? कौन कौन थे लेक्चर में? समजली का सगळ्यांना MOT. Yes sir, understood. Chetan is also saying yes sir. Okay, chalo. So the next point, filling of electrons in molecular orbital. An example is Preeti is saying also yes sir. Now this example is there. This example is there. Central metal atom is cobalt. Ligand is fluoride. 6 is coordination number and charge on the complex is 3. Now you people will draw the MO diagram for this complex. You people will fill the electrons and tell me the electronic configuration of this complex according to the MOT. चलो जल्दी से draw the MO diagram. Draw the MO diagram. So first what you have to do, what is your first job? You have to write down the electronic configuration, or before that you have to find out the oxidation state of central metal atom. I have told you while discussing first chapter, I have told you oxidation state is very important. Determination of or calculation of oxidation state is very important. So ये ऑक्सीडेशन स्टेट आप लोगों का पीछा नहीं छोड़ने वाली. आप लोगों को ऑक्सीडेशन स्टेट कैलकुलेट करना आना ही चाहिए. ठीक है. सो फर्स्ट कैलकुलेट द ऑक्सीडेशन स्टेट, फाइंड आउट द डी सिस्टम, write down the valence shell electronic configuration, then add the electrons from metal and electrons from ligand. Ligand always will give 12 electrons. So just you have to add the electrons from metal in that 12. Okay, so you will get total number of electrons. Once you get total number of electrons, you have to draw that MO diagram, and according to the rules you have to fill the electrons. That means lower energy orbital will get electron first, then the next orbital, then next, and then next. In this way you have to fill. Okay, do these things and tell me the electronic configuration. Who will tell first? Who will tell first? इलेक्ट्रॉनिक कॉन्फ़िगरेशन आप लोगों को मुझे बोलना है अकॉर्डिंग टू द MOT. सो आई विल राइट हियर. क्या करना है फर्स्ट आप लोगों को? फर्स्ट आप लोगों को ऑक्सीडेशन स्टेट फाइंड आउट करना है. देन सेकंड आप लोगों को valence shell electronic configuration ड्रॉ करना है. देन find the D system. Add electrons from metal and ligand. Then fifth, draw MO diagram. And sixth, fill the electrons. This step you have to follow. This 6 step you have to follow. Chalo, do it fast. Who will tell first? Electronic configuration according to the MOT. Chalo, guys, don't waste time. Don't waste time. That means you are not there in my lecture. I will give 0 marks for you, your internal. आप लोग अगर आंसर नहीं करोगे तो आई विल गिव 0 मार्क। मेरा दिमाग मत सरकाओ तुम लोग। मैं कुछ भी कर सकता हूँ। टेल मी आंसर। चेतन, अकॉर्डिंग टू MOT, Chetan is saying valence and electronic configuration of cobalt. No, I don't want that. I want MOT electronic configuration. The electronic configuration according to MOT. No one is answering. Chalo, I will give some hint. It is a D6 electronic system. आप लोगों को मैं थोड़ा काम हल्का करके देता हूँ. It is a D6 electronic system. It is D6 electronic system. That means 6 electrons from metal and 12 electrons from ligand. So total 18 electrons are there. Total 18 electrons are there, and these 18 electrons you have to fill in the more. बोलो जल्दी से। नहीं पता? बहुत ढीले लोग हो आप लोग। कुछ भी नहीं हो सकता आप लोगों को। बहुत ढीले लोग हो आप। सीधे इलेक्ट्रॉनिक कॉन्फ़िगरेशन आपके स्क्रीन पे। क्या है? What is the electronic configuration? Is this correct? Is this electronic configuration is correct or not? Tell me. जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन आपके स्क्रीन पे है, is it correct or not? Chalo, don't know. We will go to the next point. Take this example also. COCN6 3 minus. COCN6 3 minus. इसका आप लोग इलेक्ट्रॉनिक कॉन्फ़िगरेशन निकाल के एमओ डायग्राम कंस्ट्रक्ट करके इसका स्क्रीनशॉट आप लोग मुझे भेजोगे गूगल क्लासरूम पे। व्हाट यू हैव टू डू? यू हैव टू कंस्ट्रक्ट एमओ डायग्राम। फर्स्ट यू हैव टू determine oxidation state, write down electronic configuration, find D system, then add the total electrons from metal and ligand, and then draw the MO diagrams. Then what you have to do? You have to fill the electrons in electronic configuration, electrons in MO. ठीक है? So ये आप लोग करके इसका स्क्रीनशॉट आप लोग मुझे भेजोगे ऑन गूगल क्लासरूम, ठीक है? ओके, सो आई थिंक वी विल स्टॉप हियर. I think we will stop here. If you have any problem, any doubt, you can ask me. I'll be happy to answer your question. Hmm? You have any problem? Yes or no? No problem. Hmm? है किसी को कुछ प्रॉब्लम? नो प्रॉब्लम. किसी को भी कुछ भी प्रॉब्लम नहीं है. दैट मीन्स आप लोगों को सब लेक्चर समझ में आया. दैट मीन्स आप लोग एग्जाम में आउट ऑफ मार्क्स लेने वाले हो. बोलो. नो सर. व्हाट नो? कृष्ण प्रिय नहीं लेने वाले आउट ऑफ मार्क्स आप लोग. अच्छी बात है, मत ले लो. व्हाट इज डेट टुडे? 7/12/2020. So I will active the link for attendance. अच्छा, नो डाउट सर. ओके, नो प्रॉब्लम. नहीं है डाउट, अच्छी बात है. और अभी मैंने आप लोगों को इलेक्ट्रॉनिक कॉन्फ़िगरेशन पूछा था, तो किसी ने भी कुछ भी आंसर नहीं दिया. आप लोगों को इस साल सॉफ्ट कॉर्नर नहीं मिलने वाला. कोविड का जो था ना सॉफ्ट कॉर्नर, वो चला गया. लेकिन इस टाइम पे आप लोगों को सॉफ्ट कॉर्नर नहीं मिलने वाला. आप लोगों को अच्छी तरह से पढ़ाई करनी होगी. क्वेश्चन पेपर भी आप लोगों का इजी नहीं होगा. सो बी सीरियस. We have left only one lecture syllabus, then this term will get over. ठीक है? So if no problem, then I will stop here. Take care. Bye bye.